Example 4.6. What is the maximum power that can be delivered to the load resistor RL? Maximum power occurs when the R load value equals R Thevenin, which is of course equal to VOC times divided by I short circuit. So here we go. We're going to remove the load. Right, we're going to start with our first step. I want to determine VOC. So the first thing I'm going to do here is that I'm going to remove the load. And look for reductions and source transformations. So when I look at the circuit, I'm going to see that there, in this case, there are none. So if I'm going to go ahead and start drawing my circuit here. So when I look at this thing, I'm going to start up at the 9 ohm or 9 amps. There's 9 amps. And then I come up and here's my VOC. And then I have a resistor right here. And this is my 2 ohm. Then I have another resistor right here. Then I have my dependent. And then I have another dependent. So this guy goes like this. This is plus or minus 3Ix. This is 2Vy. And then I have one more resistor over here. And this is my 2 ohm. Here's my current Ix right there. And I have this guy right here is my Vy. And then I have a source over here, which is 2 volts. So this is my circuit right here. So if I just clean this up just a tiny bit, I'm going to bring this out to right here. And this is a 1 ohm resistor right here. So when I look at this thing, the first thing I'm going to start to do here is that because of the open, note that this 9 amp is in series with the 2 ohm. So because of the open, I see that 2 ohm and 9 amp source are in series. So I gotta go find how am I defining VOC? So I'm gonna define, I know that this guy right here is VOC. So what I'm gonna do here is I'm gonna call this guy, if I choose this to be the ground right here, then I see that if that's my ground, then this node automatically is VOC. So what I'm going to do here is that I'm going to have to start coloring nodes to figure out what do I know and what do I not know. I know what Vy is because of what we just said right here. So because of this, you could see here is that Vy should be 2 times the current of that 2 ohm, but that current of the 2 ohm is 9, so therefore this should be 2 times 9, which will be 18 volts. So that tells me that if I look at where Vy is, look at the current source, the current-controlled voltage source. No, wait, that's a voltage-controlled current source. So I have a voltage-controlled current source, which is 2 Vy, then this becomes 2 times 18, which is now 36 amps. So what I can really do here is that I could come in here and I could go, well, that's not 2 Vy anymore. This is 36 amps. So this is a not a dependent source anymore. It's an independent source. So if I start to look at this thing, now I'm going to go in and start to look at my numbers here. So here's my one node right here. So note that this guy has to be a super node. And the reason why it's a super node, because you can see that the 2 volt is not connected to the ground. But if I look over here at this other node right here, you could see that this voltage source, this node, should be 3ix since it's connected to the ground. So if I now start to look at the numbers here, I'm now going to see here. So if I now let's do the numbers, I see that I have 1, 2, 3. I have 2 red, so I have 4 nodes. So that means I have node, let's call this V1. I'm going to call that V2, plus the blue and the green, minus 2 sources. So that tells me I have 2 nodes. So if I look at this thing, you could see here is that my node, my super node, is then going to go right here. There's my super node right there. So that means if I look at this, I have a super node. Actually, I'm not going to put it there. I have a super node right here between 1 and 2. And then I have a super condition between 1 and 2. Then a regular node that I have is VOC. So then I'm going to have a node for VOC. Note that that's a known node right there, 3IX. And then I have a DC or IX, no VY. So if I look at this thing, that means I have 4 equations, 4 unknowns. So I have V1, V2, VOC, IX. So I'm going to start writing them right here, right to the side right here. So the first one I'm going to do is I'm going to do my supernode. Actually, I'm going to move it over a little bit more. So I'm going to look at my supernode. So my supernode, you could see here is that I'm going to start with V1. I have 1 resistor connected to it. And you could see here that that's going to be 1/2 V1. And that too is connected to the 3IX. So this will be 1/2 3IX. This is node 1. So when I now go look at node 2, I see that there are 2 resistors connected to 2. So then I'm going to get 1/2 plus 1/1 V2. One's connected to VOC, and one is connected to 3IX. So this is, nope, let's do this like this. And this is node 2. Now note I put a space in between that because I'm going to go with so that I'm organized in how I deal with that. So then you see that there's a 9 amp going into V1, so this should be 9. And then what other current source do I have? Note that the current source is moving out of node 1, which is 36, so then I get minus 36. So now let's look at our second node. Our super condition, right? Our super condition is then going to read what? It has to be V2 minus V1 equals 2. So then I'm going to get minus V1 plus V2 equals 2. Now I need the VOC node, and you can see here is that I have one resistor connected to VOC. So then this should be 1/2 VOC. Now note that's connected to V2, so 1/2 V2. And then I have a current source that's moving out of that node, so that should be minus 9. And then finally, I need IX here. So my DC here is defining IX, but you could see that it should be, so the polarity of this guy should be what? Plus and minus, so it should be V1 minus 3IX equals 2IX. So if I look at this guy, it really looks like this. So that's going to be V1 minus 3IX. Then I'm going to bring 2IX from the other side. That's equal to 0, but note that I can add these guys. So this will be V1 minus 5IX equals to 0. Okay, so now I have my equations. And what I'm going to do here is that I'm going to copy these guys and bring them down with me. So it's easier for me to do the matrix on this guy. So now I'm going to matrix up and get solution. So here I go. So here's my equations right here. But now I'm going to choose, I have 4. So I got V1, V2, VOC, IX, and then I'm going to have my constants. So I'm going to go after V1. So here I go. So V1, I'm going, here's V1, here's V1, and here's V1. So then I'm going to come in and I'm going to write 1/2 minus 1, 0, 1. Now I'm going to go after V2 now. So if I look at V2, I got here, 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 and that's it. So then I'm going to write, then I'm going to have 1/2 plus 1 over 1. Then I'm going to get 1 minus 1/2, 0. Now let's go after VOC. So if I look at VOC, I have VOC right here, and that's it. Wait, there's VOC up here. So if I now write this, I'm going to get minus 1/2, 0, minus 1/2, 0. Now IX. So if I look at IX, I have IX here, IX here, and I have IX right here. So I'm now writing this out here. So I'm going to get minus 3/2 minus 1 over 1. Nope, not 1 over 1. I got to write 3 there. And then I should have 0, 0, and then minus 5. Right, so there's my matrix. Then I'm going to set up my constants. So then my constants look like this here. I got that constant, that one, that one, that one. So then this will give me If I subtract that, I'm going to get minus 27, 2, minus 9, 0. So there's my matrix. So then if I do matrix magic, that tells me that VOC is equal to minus 79.3 volts. So now I'm going to go in and I'm going to do I short circuit. So now here I go, step 2. I want to determine I short circuit. So in order to do this, what do I got to do? That means I got to place a short between AB. So here I go. So I'm going to have a resistor right here. So if I look at this resistor, then I have a second resistor coming down. And here's A. And this guy's my dependent. Then I'm going to say this is B. So here's my 2 ohm, 1 ohm, and this is 3IX. So that means here's where I'm going to place my short. Here's my short, and this is I short circuit right there. So now if I finish my circuit, here's my 9 amp. Here's my 2VY. Now I have to put in my other resistor and my other source. Okay, so then I have IX going this way, and I have plus or minus VY. So since I short circuit here is a current, I'm going to think about mesh just because I can't reduce the circuit. So I'm going to go, so if I look at this, I have 4 loops, and I have 2 current sources, right? I have the 9 amp and the 2VY. So if I look at this thing here, you can see that these 2 current sources are connecting these loops. So I'm going to come in here and I'm going to say, this is 1, this is 3, and this is IX, and I'm going to call this guy 2. So if I look at this loop here, you can see here is that this is my super loop right here. So you can see that this is the direction of my super loop right here. So now you can see my 2 loops. No, that's 2 sources. So then I get 2 loops. So what I'm finding here is that I'm going to get what? I have a super loop between 1, 3, and X. I have 2 super conditions. One between 1 and 3, and one between 3 and X. I have a loop 2, a regular loop. Then I have 2 DCs. One, I have IX, and I have VY. But note, I defined that as a loop current, so that just tells me that IX is equal to IX. And then I need a solver for I short circuit. So when I add these up, I really have what? 6 equations, and I have 6 unknowns. What are my unknowns? I have 4 currents for the 4 loops. There they are. And then I have 1 DC for Vy, and then I have my solver for I short circuit. So let's go do this here. So here I go. So if I look at my first equation looks like this. It's the super condition. No, the super loop between 1, 3, and x. So if I do that, I see that I have 2i minus 2i2, right? That's for the 2 ohm in loop 1. Note that loop 3 doesn't have any, so maybe I should put a 0 here. And then for loop ix, there's only one resistor, which will then be 2ix. Now let's look at the sources. So this guy is loop 1, loop 3, and this is loop 2, right? So this is loop 1, loop 3, loop x. So now as I come through my sources here, as I come in, I have a 2, which will be negative 2 on the right side. And if I come around, then I get a positive 3ix. So then this guy's going to give me positive 3ix for the source. And then this one's going to give me minus 2. Okay, so those are my sources. So now let's look at the super conditions. So I have a super condition between 1 and 3. So if I look at that, it's going to be, I'm going to have I3 going in the direction of 9. So this should be I3, I1 equals 9. Then if I look at the next super condition, this is between 3 and x. You could see that the 3 is in the same direction of Vy. So it should be 3 minus Ix. And then I'm going to bring this to the other side here. So then this should read I3 Ix minus 2 Vy equals to 0. Then I need loop 2. So if I look at loop 2 here, note that I have 2 resistors, 2 and 1. One is shared with loop 1, and that's it. So then if I write that equation, it should be 1 plus 2 I2 minus the mutual between 1 and 2. And then I look at my sources here. So if I come around, you can see that I'm going to hit a minus sign, but it's a dependent, so I keep it on the right. So then it's going to be minus 3ix equals to 0. Then I have my DC for Vy. So if I look at my DC for Vy, you can see here that Vy has to be 2, the difference between the currents. So therefore, I'm going to write this as 2i2 minus 2i1 minus Vy, and that's equal to 0. And then finally, I need a solver. So you could see that 2 is in the direction of I short circuit, and then I have 3 in the opposite direction. So then that means here's my sixth equation, which is my solver for I short circuit, and it should be I2 minus I3 minus I short circuit equals to 0. So now I'm just going to matrix this guy up here. So I'm going to go I1, I2, I3, IX, Vy, I short circuit, and then I'm going to have my constants over here. So let's start doing it. So let's look for I1. So I got one here, 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 there. So if I start to write them, I'm going to get 2 minus 1, 0, minus 2, minus 2, 0. So that's the start of my matrix. So then let's go to the next one, 2. So here's I2, 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 I2. So if I look at this guy, I'm then going to have what? I'm going to have minus 2, 0, 0, 1 plus 2, 2, 1. Now let's go to I3. I3 here, I have it here, here, and here. So then if I write that, this is going to be 0, 1, 1, 0, 0, minus 1. Now let's go to IX. If I go to IX, note that I got IX here, here, there, and that's it. So if I write this out, this is going to be 2 plus 3, 0, minus 1, minus 3, 0, 0. Then I have Vy. So Vy, I'm going to use orange, I guess. So here I go. So I got 0, 0, Vy, Vy. So there's only 2 places for Vy. So I should have 0, 0, minus 2, 0, minus 1, 0. And then finally, I short circuit. So look at I short circuit, it should only be in one spot right there. So that means here everything is 0 except this one spot right here. So here's I short circuit. Now I have my constants. So if I look at my constants, I got one right here. So you can see that 1, 2, 3, 4. So the first 4, bottom 4 are 0. And then I have 9 minus 2. So now I'm going to matrix this guy up. So I have, excuse me. So now I have matrix magic, which then tells me here that I short circuit, I get minus 7.67 amps. So now that I have I short circuit, that tells me that RTH should be VOC divided by I short circuit. So this should be minus 79.3 volts divided by 7.67 amps. That gives me a positive 10.3 ohms for RTH. So that means then I could now write down my Thevenin equivalent circuit. Here, let me go grab the circuit. So now let's bring this up here. So then the Thevenin equivalent is, here's my circuit. And when I look at the circuit, this is equivalent to minus 79.3 volts for my Thevenin voltage. My resistance is 10.3 ohms. And now here's my load. So what load value gives you max? That's when this guy is equal to the Thevenin resistance. Okay, so now I have max power. Tells me this. So P max, the maximum delivered to the load, is then going to be max when I get, note that this is in series, so I'm going to get the voltage across the load. So the voltage splits the load in half. So it's got to be, so that's the voltage of the load. Maybe I should write it slightly different. So that should be the voltage of the load squared divided by R load. So if I use voltage divider rule, this should be 1/2 of VTH squared divided by R load. So if I do that, that's going to be minus 79 0.3 divided by 2 squared divided by 10.3, and I get a value of 153 watts for the max power of the load.